This is Algebra 2 with Trig, section 4.1. This is where we learn about factoring, and our a value is greater than 1. One method to use is called guess and check. So here we're looking at our equation, and we notice that we have our a value is what we have to multiply our first two terms by. We have our c value, what we have to multiply our last two terms by. So if we were going to sit in here with a guess and check, we know that the first terms would have to be 3x and x, because if you were to do FOIL, that would multiply to be our 3x squared. Our next thing to try is to see what's going to multiply to be 4. The obvious choice is to say 4 and 1. That multiplies to be 4. We are expecting them both to be positive because that multiplies to be a positive and has the best chance of adding together to equal a positive. When we FOIL this out, this is the checking part. We do the first, and then we do the outer, then we do the middle, and we do the last. So as you noticed, just plugging in the numbers, we got a different result. So that 7x is close to 8x, but not quite what we want. So maybe it would be helpful if we switch those around. If we put the 4 on the outside, and we put the 1 in with the 3. And when I FOIL that together, 3x and x gives you 3x squared. 3x and 4 gives you 12x. The inside is x, the outside is 4. So we get 3x squared plus 13x plus 4. That didn't help either. We want the middle to be an 8. So there's one more possible way that we can multiply to be 4. We know the last two terms definitely have to multiply to be 4. So 2 and 2. And then we multiply to be 3x squared plus 6x plus 2x plus 4. And as you see it come together, we get our 8x in the middle. That's called guess and check. You might be able to check it in your head a lot quicker. You might be able to run some of those numbers through and see what's going to be most useful. But in this case, it was the 3x plus 2 and the x plus 2 gave us our multiple. That's guess and check. I won't typically instruct us to be using the guess and check so much. Sometimes problems are set up so guess and check's extra easy, and we can discuss that along the way. Usually I'll give us a method to solve it. If you're good at guess and check, go right ahead. Please use guess and check. That is a great method if you can get the answer quickly, especially if you're checking it in your head. We're going to try and use the box. So one method here with using our box, we're going to take our 4x squared plus 16x plus 15, the x. We put our a times the c. A times the c, so when we multiply that out, we get 60. And it adds to be our b value, which is 16. Now I often talk about using a table. I like to use the table because it shows you all your possible products that are going to multiply to be 60 and add to be 16. You know that both terms have to be the same, so they're both positive or they're both negative. Since they're multiplying to be a positive, since they're adding to be a positive, they both have to be positive. So 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10. Now that is our way that we can multiply to be 60 and add to be 16. That's the only one that'll add to 16. All of them multiply to be 60, but only one of those adds to be 16. So we come over here, we put our 6x and our 10x. We put in our first term, which is 4x squared, and our last term, which is 15. You factor out of your column what number would go into both of those, and that would be 5. What number would go into both of those? That would be 2x. What number would go into both of those? 2x. What number goes into both of those? 3. So our final answer is 2x plus 5, and we say plus because the box that's next to is a positive, and 2x plus 3 because the box that's next to is a positive. What you factor out is a positive. So what's very important when we're pulling these out is to look at the greatest common factors of each of these. You could call them a binomial. You have two terms, you're factoring out your greatest common factor. To use the box, however, you need to be sure that your original problem is fully factored. You got to take the GCF out ahead of time. You cannot use the box if you have not pulled out your GCF originally. So for factoring, we talked about taking our A times the C, which is 24, adds to be the middle term, which is negative 10. You know to multiply to be a positive, they have to both be the same, either both positive or both negative. To add to be a negative, they both have to be negative. So I know my terms are 1 and negative 24, negative 2 and negative 12, negative 3 and negative 8, negative 4 and negative 6. There's my example of what's going to multiply to be positive 24 but add to be negative 10. So I pull out my box, put in the 3x squared and the 8, bring over your negative 4x, the negative 6x, factor out what you can. We can factor a 4, but I'm going to make it a negative 4 because the box that it's next to is negative. 3x, x, and a negative 2 because the box it's next to is negative. Our final answer is 3x minus 4, x minus 2. We factored our original problem. So for part B, first you want to check to be sure that the GCF is all taken out. And when we multiply those together, we get negative 90. That adds to be 1. We know that both signs have to be different because it multiplies to be a negative, and the larger number has to be positive because they add to be a positive. So we're going to say negative 1 and 10, negative 2 and 45, negative 3 and 30. 4 doesn't go into that. Negative 5 and 18. Negative 6 and 15. Negative 9 and 10. Those are all your possible ways that you can multiply to be negative 90. Now, if you don't like to write out all the ways and you know the way, then jump right to it. I'm just trying to show you a method that it's pretty foolproof as long as you can work your way through. If you don't know your multiples, just get out your calculator. Negative 90 divided by negative 1. Negative 90 divided by negative 2. Negative 90 divided by negative 3. When you get to negative 90 divided by negative 4, that'll give you a decimal, and you know to eliminate that one. It's not going to be the answer. we're looking for two integers. So we add to be 1. So we go to our box, put in our 6x squared and our negative 15, your negative 9x, and your positive 10x. Factor out what you can. Factor out what you can. Factor out a 3x. Factor out a 5. It's going to be positive because the box that it's next to is positive. The 3 is negative because the box it's next to is negative. So we end with, you can take it from either direction, but we're going to have our 2x minus 3 and 3x plus 5. It wouldn't matter if you put the 3x plus 5 first, but you cannot switch just the 3 and the 5. The negative 3 has to be with the 2x. The positive 5 has to be with the 3x. And you know that by foiling it back together, you would produce what you started with. That's the best way to check to be sure all of these are correct. So we're going to multiply the a and the c, and we're going to get negative 36. That adds to be 5. We know that the two signs have to be different. We know that the larger number has to be positive because it adds to be a positive. So we're going to have negative 1 and 36, negative 2 and 18, negative 3 and 12, negative 4 and 9. That's the one that adds to be 5. Even if you try negative 6 and 6, that's going to be the only one that adds to be 5. So we put back in our box, bring down your 3x squared, bring over your negative 4x and your positive 9, positive 9x. Factor out what you can. We're going to factor out a 4 and make that negative because the box it's next to is negative. 3x because both boxes have the x's in it. Just x and just 3. So we're going to get 3x minus 4 and x positive 3. Fully factored. And we could check that by foiling that to be sure it was the correct answer. Some special products from lessons from a previous day. We're looking at this one. We notice it's a minus. See how there's only 2 terms. So if there's 2 terms, we're already doing it different than we were just recently. So you're noticing that there's a minus in between. You see now that you can take the square root of both of those. So you would call this the difference of 2 squares. Since you have the difference of 2 squares, you can take the square root of 81x squared, which is 9x. You can take the square root of 25. If you can take the square root of both of those, there's no b value. It's a negative in between or a minus in between. Then our answer is going to be 9x plus 5, 9x minus 5. It's the special product rule for the difference of 2 squares. This one's a little different. We look at this one and it has 3 terms. So if it has all 3 terms, we can treat it just like we did to the 3 examples above. But instead of just doing that, because I'm intimidated to say 49 times 64, that seems pretty big. I'm going to see if there happens to be anything else. I'm looking to see if this is a perfect square trinomial. And to do that, we need to take the square root of 49z squared, gives us 7z. We need to take the square root of the 64, which is 8. And also, remember, we could stop with this first one like that, but we also have a b term. So we have to see, is the b term 2 times 7 times, or 7z really, times 8? Is it 2 times 56, which is 112? So it follows all that pattern. You can take the square root of the first term. You can take the square root of the last term. And the middle is twice their product. So if it is that pattern, we can just say 7z. This is a plus, so I'm going to put a plus down. Your b value is positive, so I put a plus. 8 squared. Now if you were planning to test this, you would say (7z plus 8), 7z plus 8, you get 49z squared plus 56z plus 56z plus 64. We see that the 56 and the 56 makes our 112, the 49 and the 64 are already there. We're all set. That checked. On this side, I don't really want to do 9 times 121. So I'm going to suggest, let's look at 9r squared, which is 3r. Let's look at the square root of 121, which is 11. Let's look at 2 times 3r times 11, which is 33 times 2 is 66r. Is the middle term 66r? The answer is yes. You might recognize that the middle term is negative 66r. If it's a negative 66r, we're going to say 3r minus 11. Before here we said plus because the b value was positive. Here the b value is negative, so we got to put a minus. Fully factored. Here we see that it's minus, so we need to notice that we only have 2 terms. 2 terms means that we're not going to do it the traditional way. We got to think about what are our options if we only have 2 terms. Can you take the square root of 3? Can you take the square root of 300? And the answer is no. But if you notice, you can factor out a 3 out of both of those. Now you can take the square root of x. The square root of x squared is x. The square root of 100 is 10. Plus or minus. That only works if you recognize that this is the difference of 2 squares. This one here, this is not the difference of 2 squares. And I can't take the square root of 8 and take the square root of 124 and see if the middle is 2 times that. Nope, all of that fails out. So is there any other option? Maybe a 4 can go into all of those. So if I factor my 4 out, I have that. And now I look at it, and I can't take the square root of 2, and I can't take the square root of 30, so it's not the special pattern that we talked about up there about a perfect square trinomial. It's just a traditional trinomial. So I would suggest make your table, multiply your a times your c, which is negative 60, adds to be 7. You know the two signs have to be different. The larger number has to be positive. Negative 2 and 30, negative 3 and 20, negative 4 and 15, negative 5 and 12. That adds to be 7. So go to our box. Notice we only have to use the box if we need to make the table and figure out what multiplies to be AC and adds to be the B value. We didn't need to make the table when we did our special cases. The difference of perfect squares and the perfect square trinomials are two cases that have shortcuts to them. This one, not so much. Put your first term and last term in. Bring over your negative 5m, your positive 12m. Factor out what you can. So what can you factor out of a 12 and a negative 30? But you can factor out a 6. So our final answer is 2m minus 5, m plus 6. You could test that out by foiling it together. We look here. We see that it's two terms. It has a minus sign in between. We start to get excited that this might be the difference of two squares. You can't take the square root of 7, you can't take the square root of 63, but when you start to pay more attention to what numbers are here, I recognize that they're both negative. We definitely like to pull out a negative if the leading coefficient is negative. But they both have a y involved. So this is y minus, actually negative and a positive make a minus, 9. When you multiply negative 7y with y, you get negative 7y squared. When you multiply negative 7y with 9, you get a negative 63y. So that's fully factored. Last one. Notice again how it has a leading coefficient of a negative. So I'm going to pull out the number that goes into all of these, which is a 5. So I'm going to pull out a negative 5. That leaves me with 5m squared plus 12m. Well, it's going to be negative 5 times positive 5 to give us negative 25. Negative 5 times a negative 12 gives us negative 12m, and a negative 5 times a positive 7. So now, back to our table. What multiplies to be 35 and adds to be negative 12? You might be ready for this one. If you might notice that it's negative 5 and negative 7 that multiplies to be 35 and adds to be negative 12. So if you would know that, that's great. If not, you make your table and follow through. So we make our box. Plug in your first term, negative 25m. Bring in our last term. Oh, I'm sorry. It's not negative 25m. We're trying to factor this guy apart, which is just 5m. And there's 7. Remember, you have to pull the GCF out before you use the box. So I'm using my version that I've already pulled it out. Then I have negative 5m, and I have negative 7. So I can factor out nothing but a negative 1. It's got to be negative because of the sign right before it. Here, this is going to be, well, they both have to be m's because they add together to be negative 12m. So we get m. This guy here is a 5m. This guy here is a negative 7. So our final answer is the 5m minus 7 times m minus 1. But don't forget to bring down your negative 5. That is needed if you are factoring a polynomial, is to keep all your factors together.